So the title of my talk is Imagining a Post-Climate Crisis World. What role should art and design play in the imagination and reconstruction of our world after climate change? Not only will we talk about the role that art and design can play in the communication and comprehension of complicated climate data, but also the role that art and design and artists and designers can play in the construction of climate science knowledge. Obviously, we are faced with a dire problem. The world is warming at unprecedented rates, and that is primarily due to human emission of fossil fuels and other greenhouse gases. And the projections for the next century are not great. We could be looking at anywhere from another degree to 5 degrees Celsius of global temperature rise, which would coincide with a rise in global sea level, a decrease in global ocean surface pH, and a serious decline in the September Arctic sea ice extent. Since I'm talking about the role that art and design can play, I often like to invoke Octavia Butler, one of the great science fiction Afrofuturist novelists of our time. Octavia often constructed worlds post-environmental collapse, and I feel like a lot of her work can help guide us as we imagine a future post-climate change. And I like to ground my work in this quote from the parable of the sower, and I'll just read it out loud. The world is full of painful stories. Sometimes it seems as though there aren't any other kind, and yet I found myself thinking how beautiful that glint of water was through the trees. I think it's very important in this moment for us to maintain optimism, and I'll argue that art and design can help us use that optimism to construct better worlds. One of the ways that we do that is we need to reimagine our future as one where humanity and nature truly do coexist. Most humans consider themselves part of nature, but I would argue that the construction of our current world has separated us from nature. We need to reimagine a world where we are part of nature and redefine the boundaries between the natural and the unnatural. And I believe that there's a role for art in helping us do this, helping us get to the next world. One of the reasons why I think involving art is so important is because just looking at this poll, which is replicated in many different other polls, almost 90% of Americans see scientists as intelligent, but only about half of Americans see scientists as good communicators, and nearly half of Americans see scientists as being socially awkward. So there's definitely a role for other disciplines to play in the communication and the comprehension of these complex scientific concepts. Another reason why I think there's a role for art is because art, as Timothy Morton defines it, is climate change, as Timothy Morton defines it, can be considered a hyperobject, an object that is both spatially and temporally too large and vast and expansive for our brains to truly understand and grasp and comprehend. And while we all encounter abstractions in our work, artists and designers in particular intelligently address abstraction and create objects every day. And so I think there's a very didactic role for art, and that's represented by this work by Diane Burko, which is currently part of a show at the American University Museum in Washington, D.C. You can see that Diane is creating paintings that depict various aspects of climate change, and they're both visceral and aesthetically compelling, and they drive us to think more deeply about the crisis at hand. I'll also include some work from my students that follows in this same vein. I teach at an art school. I'm a climate scientist and I teach at an art school. And so my students, as part of their final projects, create artwork that depicts various aspects of the climate crisis in an effort to better communicate the magnitude of the crisis to the general public. And I love showing this piece by Katie Wittenberg called Climate Deniers on Vacation. You'll see some very notorious climate deniers, the Koch brothers, Scott Pruitt, Rex Tillerson, sitting on top of sort of what we call in the climate community, right, charismatic megafauna, these polar bears, which kind of are emblematic of climate change in the Arctic. And behind them, there's a mountain range relief, which is actually an abstraction of the annual amount of carbon dioxide emissions that are being emitted into the atmosphere. So there's a lot contained in this image. It's also really visually appealing. It makes us think, it's interesting, and it's a bit funny. Here are some more examples from my students. On the left, we have a global warming Snapchat rant by one of my students, Mandy, where she went on about what is global warming and why do we need to care about it and what can we do about it. And on the right, this is a great video essay piece by my student Ola Wilkes-Bernays, who they researched an endangered species of bird along the Chicago Lake Michigan coastline, the piping plover. They found out what this bird eats and they baked a cake that the bird could eat. They put the cake out on the lakefront and then filmed it throughout the day as the birds came to pick at the cake, and included in that video information and facts about both the bird and the effect that climate change and other aspects of the Anthropocene are having on the population of these piping plover. But, as I said at the beginning slide, there is a role, I believe, for art and design that expands beyond this improved communication and aesthetic representations of complex scientific concepts. And I'm not the only person or the first person that has thought of this. I like to highlight this paper by my colleague AJ Purdy, who worked with a design team to redesign some drought indicators to better serve stakeholders, farmers, etc. So we're not the first people to think about this, but we're definitely expanding on these concepts and putting them to use, and I'll show you a few examples in a moment. The underpinning for this theory is a comparison between the scientific method and the design process. So the scientific method, which is depicted here in simplified version, of course it's not linear like this, there's lots of loops, there's lots of iterations, but in general, right, we learn that the scientific method begins with some hypothesizing, where we conduct preliminary research and we formulate questions. We then move to an experimentation phase, an analysis phase, and finally a conclusion. I think analogous to this process are the last 4 steps of the human-centered design process, where you have an ideation phase where you're exploring and imagining and conceptualizing designs using reflective sketching, perhaps, then a prototyping phase, which is analogous to experimentation, a refinement phase, and then finally a materialization or production phase where you're publishing and implementing your design. Of course, the glaring difference between these two processes is the first step of the design process, which is this understanding phase, where designers and other people involved in the process will empathize, listen, and learn from stakeholders and others involved so that the final product, right, the designed object, serves everyone and is actually what everybody wants and is going to work for everyone. And I argue that we can probably use a version of this understanding phase and sort of plop it right down here into the scientific method to improve the production of scientific knowledge, right, in the pursuit of hopefully, deriving solutions to the climate crisis. And so I'd like to give an example of a project that I did that employed this methodology. To give you a little bit of background, this example deals with a database that I constructed while I was still working at the NASA Jet Propulsion Laboratory of wildfire smoke plume heights in the atmosphere. And I would be remiss to start a discussion of wildfire without showing you an artistic rendering, a print that one of my students, Dakota Sherman, made of wildfires in California, of course. Anthropogenic fires are everywhere. They're on every continent except Antarctica, and they're quite ubiquitous. You can see that they are most dominant in South America, Africa, and Southeast and Equatorial Asia, but they also exist in temperate regions and in boreal regions. So this image from Sally Archibald's 2017 paper, seminal paper on anthropogenic fire landscapes, shows blue dots for every fire that existed on the landscape that was started by or is attributed to human origin. It's important for us to, as climate scientists, to understand the impact that the smoke from these fires has on the climate. And one of the ways that we need to look at this, to perform this research, is we need to know where in the atmosphere the smoke from these fires is going. Is it staying at the surface? Is it injecting in above the boundary layer? Is it somewhere in between, right? And some of my prior research from my time at JPL and previous years during my graduate studies and work looked at this problem using model data and satellite imagery, and we concluded that it is very likely that when you know, inject smoke from wildfires into the mid layer of the atmosphere, it inhibits cloud formation and reduces the ability for those clouds to rain, especially in a tropical ecosystem like the Amazon or northern Africa. And so we thought it would be worthwhile to use our satellite at the NASA Jet Propulsion Laboratory, the MISR satellite, the satellite instrument, the multi-angle imaging spectroradiometer, to compile a database of all the fire plumes that we could see across the globe. And in that database, we include every fire plume that we could see for 5 years, beginning in 2008 and extending. And included in each of those files are many data points where we use our satellite and the multiple cameras that it has to estimate the altitude of that smoke in the atmosphere, right? So we've got this very extensive, tens of thousands of plume large database, and the website to deliver these data looks like this. I would argue it's not very good. It's not very intuitive. It doesn't make sense to me. It clearly was designed by a scientist, and there's a lot of room for improvement, right? And this is probably the reason why this very important data set, I would argue it's a very important data set, is going relatively unused. Not many people use these data, and I think part of it is that there's a hurdle in downloading and analyzing and processing these data, right? As climate scientists, we're not always trained to also be computer scientists, but it seems that when you work with large data these days, you need to also know how to code, use Linux, all of these various things right before you can even do any analysis. And it doesn't help when the website to obtain these data looks like this. It's a turnoff. It's very confusing. So we thought, let's involve designers in the process and let's redesign this website. And we did exactly that at JPL in collaboration with the Jet Propulsion Laboratory, the California Institute of Technology, Cal Arts, and myself at the School of the Art Institute of Chicago. And we embarked on this redesigning process. The first step, as I mentioned, is this contextual inquiry, understanding the people and the problem. Contextual inquiry is a design technique in which people are studied in their context of action in order to build a clear understanding of what they do and need. And with this particular project, this entailed multiple interview sessions, discussions, workflow demonstrations, and sketching. Our designers were very talented sketchers, actually. And sketching is a really low cost and intuitive way to iterate on these ideas during this understanding phase, this phase that is not often included in the scientific method, right? Iterating on these ideas, creating artifacts that the team can respond to and have really helpful conversations around. Many ideas are created and thrown away. This helps saves the team effort and produces a better product in the end. So these are some examples of my designer Adrian Galvin's sketches. You can see that they are quite aesthetic. They're quite beautiful. I can't believe that this is how he sketches. This is how he draws. But these are his interpretations of us talking to him about the MISR satellite instrument. And here is his first attempt at the redesign of this website, right? So you can see that he's using sketching as a low-cost way of iterating on these ideas so that we can arrive at something that serves everyone. This co-designing with scientists, this collaboration, sharing ideas and showing these sketches allowed us as the scientists to give clear ideas of what we needed, what we used. And as we're creating this novel visualization, it's really difficult to imagine what it's going to show. And only by working in close collaboration with the design team could we ensure that we were on the right track and that we're actually going to produce something that's much more useful and in service of producing better, more usable scientific knowledge, right? So let me show you the results. I'm not going to show you the whole process that we went through because we've only got a couple minutes here, but let me show you some of the results, right? So in the background, this is what the website to obtain these plume height data looked like before we began this project. And here's what that website looks like now. You can see that there's so much more information contained just in visually opening the website. I can see a map of Africa, and I can see all these bars which indicate the plumes, right, that are available for download in each of these grids. And then the color bars correspond to how strong the fires are that correspond to those various plumes in these grid cells. So I can see that I've got lots of plumes here. I've got some really hot fires. I've got some cooler fires. I've got a bunch of filters over here that I can filter these data by before I even download anything, right? So I can start asking questions about the data without having to download these cumbersome text files or netcdf files or hdf files. Use some Python or MATLAB or other coding languages to parse the data and create these files that are then usable for us to analyze the data. Instead, I can open the website. I can see exactly what the data look like before I download anything. I can start asking questions about the data. I can change the view. I can look at XY plots. I can look at pie charts of the data, right? I can compare the fire radiative power to the plume height for, let's say, all of Africa, and I say, oh, look, there's no real relationship in these data. So maybe this isn't a question that I should really tackle at this time, right? This isn't exactly the right question to be asking. I can also sort of filter the data by ecosystem. Perhaps biome is a better way of looking at the relationship between fire radiative power and plume height, right? And again, this is all in the service of helping climate scientists then use these data to look at how fires and how the altitude at which the smoke from these fires impacts climate and how that might change with climate change, right? The interface is also dynamic. As I zoom in and out, the grid sizes adjust so I can get an even higher resolution look at the data before, again, I download anything. So we argue that this process, right, has not only made the website look better, not only made the data delivery website look better, but it's also going to help scientists as they pursue questions related to these data and ultimately make more scientists less scared to use these data. It's less intimidating, and perhaps we can ask much better questions of the data. This is all summarized in a paper that we recently had published this year. Very proud of this paper, which is published in a very interdisciplinary journal, Elementa, and the title is Reimagining Futures Collaborations Between Artists, Designers, and Scientists as a Roadmap to Help Solve the Climate Crisis. In the opening paragraphs of this paper that we wrote, we return to Octavia Butler and the work that she's done in writing this speculative fiction and imploring us to use our imaginations as her characters are constructing new worlds in the ruins of environmental disaster. Remember, this talk is titled Imagining a Post-Climate Crisis Future, and Octavia Butler, right, a science fiction novelist and an artist, posits in her public speeches that science fiction is not only about the problems of the world, but about solving the problems of the world, right? A sentiment which, when expanded to include the broader art world, suggests an important role for art in confronting the urgency of climate change. And we surmise that the propensity of art and design to harness the limitless potentiality of human imagination in a way that the post-Enlightenment scientific endeavor has historically been less able to do can provide a framework for developing sustainable solutions to the climate crisis. I had the opportunity to work with a number of artists, a number of art students of mine who engaged in this imagining of the future, and I'd like to present the work of one of my students, Eli Gilbert. They they created a project called Plastic City, where they kind of envisioned future humans living instead of on land in a city made of plastic floating in the ocean. And this is a multimedia project where they created a zine. They created an album, actually, an electronic music album, some music videos, and software to explore this city. And this is all located at this link here. Here are some images from, for example, one of the music videos that they made for one of the songs on the album. So this is a way, right, we can engage our imaginations in constructing these futures. Do I think we're going to be living on plastic floating cities? No, but this is a way for us to think beyond the constraints that we are existing within, right, to imagine a future, right? We can imagine any future. We can build any future, really, that we want. I'd like to conclude by noting that there are a lot of reasons for optimism, right? If we compare the latest 2100 warming projections for the different scenarios based on the current policies of countries around the world, it now looks like we are not headed towards the worst case warming scenario. It looks like the current policies have us on track for about 2.6, 2.7 more degrees Celsius of warming. This is still bad, this is still catastrophic, but it's a lot better than 4.7, right? So I'll conclude with this slide, which is my sort of, I'm a millennial and I like to maintain optimism. I'm often cloyingly optimistic. And so I'll just argue that this isn't the end of the world. It's simply the end of this world. But we currently have a radical and revolutionary opportunity to make the next world better, brighter, and more equitable. But if we don't first imagine the future that we want, then we will never have the future that we deserve, right? And in order to get that future, to get us to the next world, we must incorporate diverse voices, and this absolutely includes artists, as I hope that I have convinced you throughout this talk.